right, we're here today to talk about AI in the context of the auto industry. And we're going to touch on a range of topics from how to develop safe AI systems and regulations and to the trends that are going to have a profound impact on the industry ahead. We're thrilled today to be joined by Ödgärd Andersson. Since 2020, Ödgärd has been the CEO of Zenseact, a subsidiary of Volvo, with the mission to create safe software for autonomous cars and next-gen ADAS. Prior to Zenseact, she was the Chief Digital Officer at Volvo Cars, where she focused on moving the car to a software-first product. Before joining the auto industry in 2016, Ödgärd spent 20 years in telecommunications at Ericsson in executive and leadership roles, and she played a major role in the journey of the telecom networks moving from hardware systems to software and services, a trend that we're now seeing in the auto industry as well. Welcome, Ödgärd.
Thank you. Thank you so much for having me. I'm not sure I played a major role in that, but thanks for saying so.
So as the CEO of Zenseact, you're in a unique position supplying AD and ADAS systems to Volvo, the company that's best known for pioneering many safety innovations. So how is Zenseact approaching developing automated driving versus ADAS?
Yeah, I mean, our approach, and we, as a company, we were born out of Volvo Cars, and we took our best engineers who actually were part of creating ADAS way back when it started. And all of our heritage comes from the focus on safety, and focusing on safety is really at the core of the Volvo brand, and that is also what we inherited, and we're super proud of that. So our whole idea with automation was to take care of the imperfections we have as human beings, helping out when you're driving yourself, or ultimately just kind of getting the human out of the equation and driving for you instead. So it's a lot about safety for us, and that also makes it really easy for us sometimes to make decisions, because we always start from the point of safety.
And of course, AI has great potential to improve safety, but that's not a given. So how has Zenseact's AI and ML technology evolved over the past few years, and how are you using AI technology today?
Yeah, so we started out in Zenseact. We took a strategic decision that we really wanted to control the whole chain we talk about from pixel to torque, so basically having a full software stack. And the reason for that, there were a couple of reasons for that. I mean, one was that you couldn't really buy anything that was useful from anybody else that we wanted to buy from. But more than that, we saw that the evolution of the tech is so fast now, so we wanted to really be free to move architecturally and to evolve the system, and controlling the whole stack was the way to do that. And basically, I think we started like everybody did back then with computer vision and using ML in computer vision. We worked, as Austin mentioned, we worked together with Luminar, and we started also doing LiDAR perception. And actually, a lot of the effort is going into the tool chains and that development as much as actually developing the algorithms themselves. And all of that work we could actually reuse also moving to the LiDAR perception. And then now, I think recently, we're developing in parallel the next generation system. So the first generation is going out with the beautiful cars you saw before on stage, the EX90 from Volvo and the PS3 from Polestar. For the next generation, we're now moving the machine learning into more and more parts of the stack.
So one of the quirks of an AI system is that it can have an extremely unexpected output. And it's very difficult to make an AI system safe. So for Zenseact, what are the criteria that you're using to prove that an AI-based system is actually safe enough to launch to customers? And how do you think about the risks?
Yeah. This is going to be a little bit of a boring answer, because the truth is a bit boring here. It's about like super systematic system design, and then just basically always working with the parts of the design, making sure you try to anticipate all the risks, whether they're like software bugs or AI-related risks, or if there's something regarding the regulation you need to take care of. We work with those risks, and we go through all of the development stages, trying to anticipate, get a countermeasure, and then kind of always monitor that the system is behaving the way we expect.
But what about simulation? How important is simulation for AI safety at Zenseact?
I mean, simulation has been important actually from way back in the start of ADAS, even before we existed as a company. And it's, I mean, driving is eventless most of the time, which is a good thing, but it also makes it really hard to verify things by just driving around. It really becomes the needle in the haystack approach. So we believe a lot in simulation, and obviously we try to create all the crazy things that can happen in simulation, run all our software versions against that simulation. We talk about it as like the Murphy's drive, where everything that can go wrong goes wrong, but in a simulator. And then we just make sure that every new version of the software actually works for that.
Really interesting. So in traditional software development, we're always thinking about the safety of code, but in an AI system, a lot of the behavior really comes down to the data. So tell us about your thoughts on data curation and what makes a strong data curation pipeline.
Yeah, I mean, this is really growing in importance. I think we used to have a lot of emphasis on software craftsmanship and all of that related to rule-based coding. The whole data pipeline now is growing in importance as more and more becomes machine learning. And I mean, first of all, it's like trash in, trash out. If you don't have good data, then you're not going to get a good result in the algorithms. And as I said, most of the driving we do is also quite eventless, and we don't need like millions of hours of eventless driving on an empty road. So the whole trick, and it's also super costly, and we collect only in our test cars like petabytes of data every week, and we cannot store all of that. We can't afford it, and we don't want to, because most of it is not that useful. So basically having an automated pipeline that curates, picks out the kind of diamonds from the gravel in the data and makes sure we can run that in simulation is really key.
So with regards to data, Zenseact published a pretty interesting, very large, diverse data set publicly, and even has a pretty, I would say, generous license for really anyone to use it. What were your goals when you published this data set?
It's actually, we had a few different thoughts on doing that. And first of all, for the sake of transparency, we don't publish all data. So some of it is our secret sauce that we keep for ourselves. But we believe a lot in working with the academic community, and they need data. And I think this has been a big shift where we really need to participate as industry in giving access to that. But we also believe fundamentally that data is needed for a broader perspective. And I talked a little bit about our heritage from Volvo Cars and the safety thinking. And way back when the 3-point seatbelt was invented by Volvo Cars, they decided to kind of open up the patent for that because they saw the impact it could have and how many lives it could save. And we actually think about that when we publish our data sets. We have a little bit of an ulterior motive as well. We have noticed that it's a real good attraction of talent. So people who have come in contact with our data set are finding us and we're finding them. So.
Really interesting. Related to that as well, Volvo's published Volvo rather has an extensive database of crash data. My understanding is that's been studied pretty carefully. What have you learned from that crash database, and how has that helped shape your ADAS development and even your choice of sensors?
It's a cool choice. As the 3-point seatbelt was invented, a lot of people said it wasn't safe and it was no good. And so a few really foresightful people decided to collect data to prove that they knew that it was safe and they wanted to prove it. And that tradition carried on. But for us, it's been super useful. Every single severe crash is documented and we have the data. So when we make decisions, we go through all the data. And we do that for selecting sensors like the LiDAR. We go through all of those really severe accidents, and we estimated with a conservative estimate where we would have been able to avoid that accident, and we easily reached 20% improvement. And then that is a really good support when you make the decision to put a somewhat expensive sensor on a car.
So with regards to that sensor, so the LiDAR, which is mounted above the rearview mirror, it's a pretty bold industrial design. Personally, I really like the way that it looks. I think it's very distinctive. What are the advantages of standardizing on this configuration as opposed to maybe having a variety of configurations that are typically the case for sensors?
Yeah, I mean, the obvious thing is that we get to have one software track, we can use all the tech that we actually developed for autonomous driving for ADAS. When you have one standardized sensor set, you can collect data from every single car. Whether people buy the most advanced software or not, you can still use it for data collection. And we're able to reconfigure and kind of upgrade the software over time, and it keeps the development effort minimum because we can keep one track and keep adding new customer value instead of kind of spreading on multiple different configurations. So it's really for speed and for safety on the broader perspective. And the design, I think, we normally talk about this. You don't see a lot of animals with their eyes on the knees. So it looks a bit unusual when you're not used to it, but I think in the future we will be used to seeing sensors that are high enough to make a good impact.
So the US regulations are fairly lax when it comes to data collection for AI in vehicles, but Europe's actually much stricter. So how do these regulations affect how you're developing your products?
Well, obviously we need to follow regulation, right? But it's different. We both have the US regulations, we have China regulations on data where you can't actually move data out of the country. We have different environments, and we want to have a global product. So somehow we always try to find a way to deal with things that makes it possible to be global. And things like wanting to protect the integrity of people. We don't really want to know that you, Peter, crossed the road together with a friend and see your face. We want to know that there was a human being there and that we can recognize you as a human being. But altering your face is not a problem for us. We're actually happier not to know exactly what person was there. That means we never have to answer that question either. So,
really interesting. And what about when we talk about software upgrades? And how does software updatability play into these regulations? Maybe in the case where regulations weren't written with the mindset of upgradable software.
Yeah, and here I think the regulators have a lot of work to do, actually. Most of the regulation comes from a background of mechanical products that were never upgraded. And I think most of the regulators realize they have to do something differently, but it's not in place yet. And I mean, it would be totally irresponsible if we cannot update our software systems when it's technically possible. We can bring more safety, we can actually save lives. We need to make that possible with regulation. At the same time, I have full respect. We don't want a situation where people are just throwing software out that's totally irresponsible. So we need to reach a new level of responsible software launches and regulation that follows that.
In your view, how much of that responsibility falls to the regulators versus the companies who are thinking about their stock price and protecting their reputation?
I mean, we have to, of course, be responsible as companies, but I think we also have to have a very active dialogue with the regulators. So I think one of the problems is it's not that easy for a regulating body to have the competence in software you need to actually understand what would be a good regulation. We need to pitch in, I think, and help out. Most of us have a real wish to make responsible choices but still upgrade our software.
So let's talk about Euro NCAP, which of course is one of the most important regulations. So today it's a fairly simple set of tests, and it's certainly not fully representative of real-world conditions. So what do you think about the current state of Euro NCAP for ADAS, and how do you think that NCAP should evolve as software and AI continues to advance?
Yeah, I mean, rating institutes in general, I mean, the idea is to give the consumer better insight as to how do you choose a safer car. And of course, it doesn't help a lot if all the cars get 5 stars. Then you're not really helping the consumer. And I think they've actually been quite good at that. In Euro NCAP has over the years become much more difficult to pass. So you kind of raise the bar as the progress happens. And we actually talk to them quite a lot, and Volvo does as well, with their kind of focus on safety, and we give input. I think now what I would like to see is that those of us who are making major moves in safety, like for instance sensors that can see in the dark, should be rewarded for that. And I mean, in the US here, 6,500 pedestrians are killed every year. And 80% of that happens in the dark. And we can help that. I mean, if you have an active sensor like a LiDAR, you can actually see in the dark. And then I think the ratings should reflect that and have use cases in driving in darkness. I also think software that can be upgraded and improved should be rewarded. And I think lastly, and this is maybe a little bit more futuristic, I think all cars are becoming connected, and we have the ability to actually extract real-life data. And if you're really interested in real-life safety, I think as a consumer, we should be able to actually compare not just what you tested up front and how good an OEM is at making a certain number of test cases work, but actual real-life data should be a part of the rating, I think.
Now, some of the next generations of Euro NCAP, they involve things like being able to track obstacles that are around curves. And so it starts to get into the realm of map data being important. We'd love to get your thoughts on sort of the future of map data in ADAS, and how do you view maps being a critical part of the safety?
Yeah, I mean, this is an interesting topic that I spent a little bit of time thinking on. We work with Google, as you might know, with their HD map, and it's actually really good. You can make kind of the horizon be a little bit farther out if you know where you're going. You can make a lot smoother driving with a map, and that is in turn quite a lot safer. If you have like lane level precision, you can make your choices in decision and controlling where to move in a lot better and more foresightful way if you have a good map. On the other hand, a map always has the risk of not being updated in real time. So, I mean, it's a little bit really good, and also you need to know the limitations.
Mm-hmm. So, be it maps, AI compute, sensors, advanced software, all of these things, they're not cheap when you add them all together and put them on a vehicle. And at some point, these systems become too expensive to be practical to sell at high volumes. So how are you thinking about the trade-offs between these cost of these systems and the safety that they bring?
It's a really difficult area, I think, because you don't really, on the one hand, want to put a price tag on a human life or human suffering. On the other hand, if a car costs $1 billion, nobody's going to buy it, and you're not going to make any difference. I think what you can see is that you can make a lot of business cases based on reality right now, and you need to also be a little bit aware of where is the world going. And most tech has a tendency to come down in cost, especially electronics. So what might seem as a super difficult decision today to standardize on a certain amount of hardware, you can project that it will be a bit cheaper in the future. I'm really, really happy and proud, actually, of Volvo Cars for standardizing on the advanced sensor set they did now with the new generation of cars. I think as we move along, we see the trend that we've seen before. Things are coming down as they commoditize and become more widely deployed. Back in the day when the airbags were first invented, some OEMs like Volvo standardized. They were early out, and everybody thought they were super crazy. And then now we all take it for granted. Yeah.
Really interesting. So looking ahead, with advances in generative AI, including transformers and large language models, how do you see the next few years evolving for AI in automotive safety systems?
It's like you don't even want to get that question, because it's moving so fast now. Whatever I say now is probably going to be totally obsolete in 2 or 3 or 5 years, right? So, I mean, it's advancing and spreading. Before as I said before, we were mostly in the perception area. Now we see kind of machine learning moving across the code base. It will continue, and we just need to keep up.
And then along those domains, there's a lot of buzz right now around this, the concept of a full end-to-end self-driving models being used. And that really means that sensor data goes in, and then vehicle control comes out, all of one giant model. Do you think that this can be safe?
Yeah, we currently don't believe in that approach, and for the reason that it becomes totally untransparent what happens, and if something goes wrong, there's like no way to actually know what the system is doing. So we do believe in using machine learning across the chain, but we kind of partitioned it a careful system design to be able to know what the system is actually up to, and to be able to monitor and then correct when we need to.
Do you think that it's at least, let's say, an interesting area of exploration, or have you more or less ruled out that it's just going to be too difficult to make safe?
It's not the approach we're taking right now.
Mm-hmm. Makes sense. Zenseact has also talked publicly about federated learning as an area of interest. So what is federated learning, and how is it relevant to European privacy regulations?
Yeah, I mean, this comes both actually into play in Europe and China. So what we believe is, firstly, we have all these amazing computers being deployed in cars all over the place, and most cars are driven like 5% of the time, and the rest of the day the computer is just sitting there. Also, uploading the amount of data that we do is quite expensive. So we believe in actually using the computers in the cars to train our models locally and then share the trained models across the network and learn in a federated manner. That also means that you don't need to let the data actually leave the car, which has many benefits from a privacy or regulatory perspective. This is not production code. I will say we're doing research on this, and so this is more into the future.
Really interesting, and I can imagine this then sort of playing into thinking about the compute that's going to go into future vehicles, and even getting into charge network infrastructure. Hmm. So looking ahead again, what advice do you have for other automotive software companies that are looking to make better use of AI in their products and services?
I don't think you have much choice whether you want to or not. Get into it and start learning if you haven't already, and run as fast as you can, because it's moving crazy now.
Terrific. And maybe lastly, wrapping up, what are you most excited about looking forward?
Yeah, but I mean, I want to save lives. That's what I'm excited about. And this whole, I mean, we talk about the safety risks, but the opportunity is so big. Like 1.3 million people, we can save those lives, and the 50 million that are injured every year. And that's what excites me.
Awesome. Well, terrific. Thank you, Ödgärd.
Thank you.